Welcome dear students, we are on the CEC-UGC lecture and we are in the series of electronic circuit. In the electronic circuit, we are discussing one of the important component, that is the resonator. We have defined the many type of resonator. In the last series, we discussed about the optical resonator and we discussed the various type of resonator in the last lecture. Now, we will discuss further the different types of the optical resonator. So, today we will discuss some of the optical resonator. In this types, first we take the spherical and the cylindrical resonator. These resonators are characterized by their distinct curved geometries, as it is spherical and cylindrical, so they are just recognized by their curved geometries and which offer unique advantages for the light confinement and the formation of the whispering gallery modes. Means these type of resonators are used in the laser circuits, and these modes result from light waves that propagate around the resonator's inner surface with minimal loss. Because of their shapes, because of their geometry, we are having a very less loss in the resonator circuit because of the geometry of this distinct curved geometry of this spherical and cylindrical resonator. So, we are having very less loss of the beams. In this resonators, we continue that they are utilized in cavity quantum electrodynamics, that is QED, LED and QED, that is a quantum electrodynamics experiments. High Q resonator for the ultra sensitive measurements and having a single photon studies. And they are also find use in the frequency stabilized laser and optical biosensors. Now, you see on the screen on the right hand side, at the lower side, we have the spherical and we have the cylindrical type of the resonator. With these spherical and cylindrical optical resonator are both used to confine the light within a cavity, but differ in their geometry and how they affect the light propagation. Means both having its own characteristics. If we talk about the spherical resonator, they use the curved mirrors to focus the light into a small volume, enhancing light matter interaction and offering stability. And on the other hand, cylindrical resonator on the having a cylindrical shape and often described by their inner radius and height, and they are used for the application in the microwave transmitters and the filters. So, you can see the type of the you can have the different type of the resonator, spherical and cylindrical resonator, and they have different characteristics and they have different utility. Another type of resonator is the whispering gallery mode resonator, and this WGM resonator are a class of high Q optical resonator that exploit the unique properties of whispering gallery mode, and these resonators typically the micro scale in size and can be fabricated using a variety of geometries like the spherical, triodes and the disc. Means these type of resonators having the various type of geometries in the form of the sphere, triodes or the disc. And apart from this, light waves travel along the resonator's curved surface with the minimum loss due to the total internal reflection. Means in this type of resonator, we are having the total internal reflection, and this type of WGM resonator find the application is optoelectronic oscillators, highly sensitive sensors and the single photon sources, as well as in the non-linear optics we have use of this type of resonator. Nowadays, quantum information processing, we use whisper gallery mode resonator, and as there is a total internal reflection, we use in the fiber optics also. So, you see on the screen there are the various type of resonator, and these are generally used in the laboratories just for the different type of functioning. And Then what is the example of the WGM resonator, which is the sapphire micro. These are the micro resonator, and these are made from the sapphire as and are used precision temperature sensors. Another type is the silica micro resonator, and these are made from the silica and are used in variety of application, like we just include in the biosensors, and moreover we use in the optical filter. So we use these type of sensor in various type of biosensing devices, and optical filter, like optical filters, we are using that in the laser systems, where we just require the one type of the monochromatic light we require. Another is a tapered optical fiber micro resonator, and these are formed by tapering the diameter of the optical fiber, and this can be used for sensing and coupling and for the transformation of the transmission signal from one place to the another place. So these are the very much important in the nowadays technology. And how this WGM works, these are the light, here we are having the coupling system. So light is coupled into the resonator typically through a fiber optic cable or a prism. So the light then undergoes total internal reflection, and it travels along the curved boundary of the resonator. As there is a total internal reflection and it is moving under the curved boundary of the resonator, so we can use it for the flexible type of the system also, so that the light will bend accordingly. The light continues to circulate, forming a resonant mode, that is the whispering gallery mode, and changing in the surrounding environment such as temperature or refractive index, we can alter the resonant frequency of the WGM type of resonator. Means if we change the temperature or refractive index, or change the material, then we can have the change in the frequency of the resonator, so which can be detected by the resonator. What are the application of WGM? And these type of resonator are used in the variety of application, that is in the sensing, and they can be used to detect the change in the temperature, pressure, refractive index and other physical parameters. And what type of other type of applications are, they are used in the optical filter, as optical filter that where we select the specific wavelength of the light according to the optical publishing group. Another type we can use in the lasers, and they can be used to create the stable and narrow line width lasers. Another is biosensors. They can be used to detect the biological molecules like DNA and RNA. Another type of resonator is the photonic crystal resonator. As it is name suggests, photonic crystal means we are using the photonic crystal to prepare the resonator, and these resonators are formed using the periodic dielectric structure, and that is the photonic crystal. Means we know that photonic crystals are the periodic dielectric structured crystals. So they can be manipulate light on a sub-wavelength scale. So by creating localized defect states within the photonic crystal, optical modes can be confined, and that leading in the resonant behavior, that leads in the change in the resonant frequency. So photonic crystal resonators are employed in the compact high efficient device, such as they are used as a filters, modulators and in the lasers, and they are also being explored for use in the quantum information processing and sensing application due to its ability to confine light with extremely low losses. In the photonic crystal resonator, there is a structure which is made of the periodic arrangement of different materials, means we can have the doping also in this type of photonic crystal, typically with altering high and low refractive indices that allows for the confinement of the light within the defined region, creating a resonance effect at a specific wavelength. So, these resonators can be used for various applications like sensing, like optical filter, like integrated photonic devices. You can see on the screen, this is the type of periodic arrangement of the photonic crystal, and you see that here is a backward and forward drop pot, and as it is a, we can say that it is a periodic arrangement. So, it is defined the periodically arrangement of the crystal, and input one port is the input port and another port is the transmission port, and here is a spherical hole that is used to generate the resonator. So, photonic crystal resonator, which are defects or irregularities in the photonic crystal structure, have a wide range of application due to its ability to control and manipulate the light. So, they are used in the area like the optical communication, sensing, laser and more. In the optical communication, and they are used as a waveguide and the splitters. So the photonic crystal resonators can be used to create the devices that guide and divide light signals. As it is the splitter, so it can divide the light signal, which is crucial for efficient optical communication network. Another type of application is the optical communication. They can manipulate and control the transmission of light in the optical fiber, so that it can improve the performance of the optical fiber. Another is a slow light devices. These resonators can significantly slow down the speed of light and enabling the new functionality in the optical communication system like reversible optical encoding. Another type of application of this type of resonator is the optical wavelength multiplexers. They can be used to combine and separate the multiple wavelengths of the light, which is important for the high capacity optical communication. So, we can have the different type of resonator. Another type is another application is the sensing, means we can prepare a optical sensors by using the resonator. So, photonic crystal resonators to interact with the specific wavelength of light makes them ideal for creating the high sensitive sensor, and that can detect the various substances, type of the substances as well as the environmental changes like temperature, pressure and the vibrational mode we can find out by using the optical sensor. Another is a biochemical sensing that can detect the mechanical forces, temperature and the solvent concentration. And by using this biochemical sensing, label free biosensing, that specific target molecules are detected without labeling. So, they are the various. Another application is the laser. Photonic crystal lasers are incorporating the photonic crystal structures into a laser cavity leads to compact, efficient and narrow bandwidth loss. And distributed feedback laser, these resonators can be used in the design of distributed feedback laser diode, which are important for various applications. So, there are the various method, and each type of optical resonators offer the unique advantages and capabilities, and making them suitable for wide range of application across various industries, research, moreover the scientific field. And we are continuously exploring the new resonator design and materials to further expand the potential of the optical resonator in the emerging technology. So these are the very important. So, on the basis of that we use the resonator, which was it is the component and the material. So, what are the optical resonator components and what are the material we use in the preparation of the optical resonator? So, optical resonator rely on the several critical components and the materials, in which we have the mirror, gain media and the coupling element. So, here we discuss the 3 points. One is the material which we are using for the preparation of the optical resonator or the components, that is the mirror, gain media and the coupling element. First is the mirror, as it is very simple. These are the dielectric mirrors and made from alternating layers of the material with different refractive indices, as mirror having the different refractive indices, so that define the various frequencies of the resonator, and this offered the excellent reflectivity and low absorption. And the metallic mirrors on the other hand provide the high reflectivity, but may also be exhibit the higher absorption and the dispersion. So, we just require the good mirror so that we can increase the reflectivity. Another is the gain medium. The gain medium, which can be the solid state medium, and that must be the gas base or the liquid base, or it provide the necessary amplification for the light waves. As we require the more gain, so we require the amplification for the light waves circulating within the resonator. So, on the basis of the medium, we can get the, that may be the solid state, that will be the gas base, that may be liquid base. We require the amplification, and that light waves circulate within this resonator will provide the minimum loss, so that we can get the required frequency through this resonator. Another point is the coupling element. This fiber couplers and the waveguide couplers are used to introduce the exact light from the resonator cavity, ensuring the efficient coupling with the minimum loss. That as we use the fiber optics, we to having a total internal reflection, again we require the maximum output and the minimum loss. So, what are the application of the optical resonator? We have already discussed the many application. So, some of the prominent application of these devices, which includes we use in the lasers, in the optical fires, the optical sensors, optical clocks and the frequency comms, and telecommunication and data processing. If we talk about we use in the laser, so optical resonators are at the core of a numerous laser system, which provide the control over the wavelength, over the power and the beam quality. And if you talk about the industrial setting, lasers with the optical resonator are used for cutting, welding and engraving material, as well as for the surface treatment processes. So, in the medical field, we can use for diagnostic, as a diagnostic tool. We will use the like we have the optical coherent tomography, that OCT, that use the optical resonators are also indispensable in various scientific research settings, including the various laser spectroscopy, laser cooling and just study the non-linear optical phenomena. Another important application is the optical filters. Resonators can function as a wavelength selective filter, critical or numerous application. As we require the single wavelength or the multiple wavelength, then we use this use as a optical filter. In telecommunication, optical resonators are employed in the wavelength division multiplexing system to filter and route the signal in fiber optics networking, and they are also enable the creation of highly selective sensors that can detect the specific wavelength, making them suitable for monitoring environment, biomedical, industrial parameters. Additionally, optical resonator can act as a filter in the spectrometers, enhancing the accuracy and resolution of the spectroscopic measurement. These are used as a optical sensors also. These resonators are vital component in the various type of the sensors like environmental monitoring. Optical resonator based sensors are used for track the air quality, water pollution and other factors. In the biomedical, we can use for the various psychologically parameters of medical diagnostic, industrial processing control, sensor. Optical resonators can measure the parameters like temperature, pressure, chemical concentration, ensuring the process stability and safety. Optical clocks and the frequency comms, we use this resonator. So optical resonators play a key role in the ultra precise time keeping and metrology. So advanced GPS technology rely on highly stable optical resonator to maintain the precise time synchronization for the accurate position determination. So optical resonator are also crucial components in the atomic clocks, which provide the foundation for international time standards and enable timekeeping with unprecedented accuracy. In the telecommunication and data processing, we use the optical resonator, which have made their mark in the field of the information technology also. Integrated optical resonators enable high speed communication between the different parts of the microchip, and that reducing the latency and increasing the data transfer rate. Through the optical fiber, we transfer the data. So optical resonator can also be used in reconfigurable switches and routers for efficient data routing in optical network. And these having the potential to enhance the data storage technology by allowing for higher density optical storage and the fast read and write options. So some of the most promising area for exploration, including the photonic crystal resonator, micro resonators and on-chip integration, metamaterial and their application in the quantum computing and communication. And there are the many type of the resonator that are used in the various field. If you talk about the metamaterials in the optical resonator, they are the artificially engineered structures with unique properties not typically found in the natural material. By incorporating metamaterials into the optical resonators, we can achieve the unprecedented control over the light matter interaction. So metamaterial based resonator have a potential application in the super resolution imaging, clocking devices and enhanced the non-linear optical processes. So the fabrication of large scale high quality metamaterials is a major challenge. So as a potential for the increase the energy losses due to the absorption and the scattering. Another, nowadays we are having a technology development era. So these optical resonators are used in the quantum computing and quantum communication, and they play a crucial role in development of the quantum technologies by facilitating precise control of single protons and enabling the strong coupling between the light and the matter. So optical resonator have been employed in the quantum computing for qubit storage and manipulation, as well as the quantum communication system for secure data transmission, and building large scale quantum system with high level of precision and stability in the complex task requiring advantages in the resonator design, material fabrication techniques. So finally, optical resonator have come a long way since their inception with numerous type and application now available across the various industries. Thank you very much.